Now, moving on, we have some great tips now, really, in this next headline presentation. From AXA Insurance, I'm delighted to introduce their Group Chief Data Scientist and Head of AI Research and Thought Leadership, Marcin Detyniecki, to tell us more about teaching AI to be fair and the lessons learned. Please welcome Marcin to the stage.
So the first time I start thinking about artificial intelligence and fairness is actually when I arrived to France. I grew up in South America, and I didn't speak very well French. And I arrived to France, and I had to attend these philosophy classes, right? And sometimes when I study a lot, I had a very bad score. Sometimes when I didn't study anything, I had a very good score. So was it this fair? I see some people like, yeah, it's a problem. There's some injustice in this. What's troubled me even more is that my professor told me, you know, I want to be fair with you. I'm going to give you some extra points because you don't speak very well French. Well, that was cool for me, but actually, it was fair for the other people in the class? I don't know. So actually, this is why I decided to study mathematics, because mathematics is very, very objective. It's either true or false. And this was a very, very fundamental choice for me to study mathematics. But let's come back to fairness. What is fairness? If you take the dictionary, you will see it's about treating people impartially. It's about treating people equally. Sometimes it's even about having some sort of rules that you need to conform. So great. What better than a machine? And by the way, machines are based on algorithms and mathematics. So what better than a machine to be impartial and to conform the rules? So let's go for it. Let's try it. So we have this real example. We want to hire very good engineers. And we want to be impartial. We have tons of CVs. And we have the history, what happened to the CV. We read the CV, we did an interview, and we didn't hire, we see what happened. Then we say, OK, we want to conform to the rules. So we don't want to look at the gender. And so what we're going to do is we just erase the delete. We delete the gender. We take it away. The system has nothing about it. And then we train the AI by showing examples. We train it. This is the way we do machine learning, right? We train it by showing examples. And then we have a very cool algorithm which is able to predict, based on the CV, if it was a good hire, at least in historical terms. This is great, right? We have impartiality. Everybody's treated really equally, and we even conform to the rules because we don't use the gender. Now, this produces a black box, as you all know. Very often, we have a black box, and if you look inside the black, so if you have some techniques, you could find something like the AI learned that if you have a hobby or a sport, which is American soccer, American football, then you hire. Well, there's something wrong with this, right? There is something that you feel, oh, but most male like American football. So there's something wrong with it. So I will come back to this bad feeling that you have about fairness here. But before, let me tell you one thing, the first lesson, which is very, very, very important, and it's about these black box effects. And this happens very often. It's not just about fairness. Actually, during my career, I saw this several times. And this is all about the fact that what you teach to an AI is not necessarily what the AI learns. I remember myself working at the University of Berkeley and trying to, long time ago, and then trying to learn in an image what is, if it's in a portrait, what type of image it is. And the system will learn very, very efficiently what is in the background. Well, this is not necessarily what we want. We don't want to have decisions based on the background. So lesson one, it's really important. I will come back to this later. Teaching an AI, what you think you teach is not necessarily what you think the AI is learning. So let me come back to this bad feeling we had about this bias or something. Let's look back at the definition again. And we see that actually, if you look a little bit more carefully, we have something about discrimination. Sure. But we also have other notions. We have the notion about being just, about being right, about being reasonable, about being honest. And actually, these things are very strong, very human, And this is all about being in conformity what is morally upright or good. And if you think about it, it creates a tension with the impartiality. Actually, the professor, my philosophy professor, she was right. She was reasonable. This guy has no idea about the language, so he has a handicap. Let's help him. Let's give him some extra points. But there is a tension with impartiality. And this, I see it all the time again. This is the discussion that we have in the Commission, European Commission. These are discussions we have at the regulators level, think tanks, OECD, everywhere. And this animates the debate about human versus machine. Yes, yes. Machines actually are very impartial and coherent. They do always the same. And they're much better in that sense for humans. But actually, we expect some more from fairness than that. So the lesson 2 is very simple. Fairness is more than impartiality and rules. And this is a challenge for artificial intelligence. So let's try now to teach fairness to an AI. Because, OK, I can teach stuff, so why not teaching directly fairness to an AI? So how do you teach AI? I said, as an example, you can give examples. You show examples. OK, great idea. So we need more fair examples. The question is how to find this, how to obtain more fair CVs, how to obtain more ladies who are applying and were selected actually in the thing. So there is research in this domain. Actually, we work on this. We use something called the variational autocoders, which allows you to create, let's say, fake CVs, and you can kind of fix the bias in some sense. But remember lesson 1. Even if we do this, it's very difficult to know what the machine is really learning. Although we teach it, we think we're teaching it something, it's not necessarily learning what you want. So what can else we do? Well, there is something which tells the machine or the machine learning what is good and what is bad. And this is a function, a mathematical function. We call it the metric, right? And we're going to use this metric to compare what is happening in 2 groups. For example, the females versus the males. And we're going to try to understand if they're being treated actually equally, right? And this metric is very fundamental. So we try to do this, actually. We try to implement. Seems very simple. And what I'm going to tell you, once I tell you that, you're going to say, yeah, that was obvious. But you will see it has profound implications in our society. So we try to implement it. And what happens is you need to know who the males and the females are. You need to know who the colored people and the white people are. You need to know what religion, if you want to protect the religion. If you have vulnerable people, you need to know that. And this is very, very profound. So teaching AI to be fair implies that you have to have some access to sensitive information, and this is counterintuitive. You want to protect the people, but in order to protect them, you need to provide, or somebody has to have access to this information. It's extremely profound. OK, lesson 3. Let's try now write mathematically, my goal, write mathematically what fairness means. When you sit down, you have use cases, and you try to write this formula. And you encounter all sorts of problems. So for example, you have errors. For example, you train a system to predict if somebody should go to prison or not. What if a false positive error has very strong consequences? What happens if my system sends an innocent to prison? I mean, this is kind of a problem. What about base rates? OK, we want to treat everybody equally. What if, should we treat people equally, for example, men and women the same way for prostate cancer? Or for breast cancer, for that matter? So actually, in this case, we don't want anymore. We want that these proportions are preserved, and not that they're equally. What about policy? Maybe what we want has nothing to do with the data. What we want is just that we have half of the people are men and half of the people are female. We want in the parliament half and half. We don't care how many applicants are there. We don't care how many people study for this. What we want is to have half and half. So these are all very fundamental questions that you need to answer, and you need to write in a mathematical formula. The good news is that everything, when you compare what the reality is with the prediction of AI, everything enters into this matrix. You have true positive, so you got it right. The true negative, you also got it right. And then you have the false negative, false positive. Horizontally, you have what you expect. And vertically, you have what the system decided. And what is amazing is that most of the fairness metrics can be written based on these 4 things. This is great, right? Because you don't have to go all over the place. Bad news is, and what you're going to do after that is that you're going to use this metric, and this metric you're going to use it to compare, as I said, just as a reminder, that you have a male and females, you're going to compare these metrics. Bad news is that all these things are connected now, right? You have mathematically, they're connected. You have false negative, false positive are used in all formulas, which means that when you try to optimize something, well, you're going to decrease something else. And you can feel it, actually, in an example. Do we want to have no criminals in the street? Or do we want to have no innocents in the prisons? You see, there is a tension there. And this is, in mathematics, you can prove it. You cannot have it both. So lesson 4 is the truth. It's very strong. Again, it's about the fact that, in fairness, unfortunately, you cannot have it all. It's about the choice. It's a choice in your for your use case, for your context, and so on. So based on this, we decided to work on something we call the Fairness Compass. So Fairness Compass is 2 things. It's a booklet in which you can, by the way, you can download it from online, and in which you have the definitions of the very fairness metrics out there, and there are examples to try to make it more clear and so on. But it's also a tool which you can also find online. It's on GitHub. You can change it, by the way. And it's a tool which is intended to help you find the right metric for your use case. How does it work? Actually, it's an algorithm, a mathematical algorithm for humans. This is what I know, mathematics. And so I propose to have an algorithm for humans. It's a decision tree. And what you're going to do, you're going to start on the top. Interactively, you're going to have questions such as the policy, the one I mentioned just before. What do you have a policy? Do you have a policy? Then we're going to talk about the best rates. Then we're going to talk about the ground truth. Is it available or is it not available? And is it important a false positive or is it not important a false positive? You're going to go through this, and you're going to find, finally, a metric. And you're going to have the right metric for your problem. For free, you get transparency. Because actually, all your decisions are recorded, and you have, in a way, the explanation of how did you choose and why did you choose this metric for your particular case. So this is extremely interesting. If you're interested, please visit our website, and then you can see it. So let me come back to let me finish, with my last lessons on AI fairness. I think we talk and think about fairness and AI a lot. And here we are, right, doing this, and I think it's really great. But I think it's really time, and this is really a call for action, to go further and implement it. This is what I did, actually. You know, I went for mathematics. This is what I liked as a child. And I like it because of an objective nature. So I try to describe fairness mathematically. And I understand this is limited. Some people may react at the end of the presentation. But in this quest, I believe I moved the needle a bit farther. So yes, please, let's try all to go from thinking, talking, and debating to try to implement it. Because by doing this, you're not going to only to understand what you mean by fairness yourself, but I think we're going to get closer to a much more fair world. Thank you for your attention.